Dear students, in supplementary examination with question in chemistry, in question number 25 or 26, the question will be from a chapter coordination compounds. In that chapter, one question will be there. So that is the most important question. Out of four examples, one example will come in examination compulsorily. So we are going to deal with all the four examples now in this class. So for there will be question like this: using VBT, account for geometry, type of hybridization and magnetic property of a complex. I am taking one example: COF6 minus 3 charge. COF6 minus 3 charge. For these complexes, you have to write three things, 3 points you have to write. So the first point will be for the hybridization. Hybridization. For this hybridization, there is a process, there is a some of the things. I'm not going to all those things directly. I will tell the how to write hybridization. There are COF6, CO cobalt is a central metal atom and fluorido is a ligand. Fluorido is a weak ligand and there are six fluorido ligands. There are six ligands. You have to go with this six ligands are there. Based on that, you have to write hybridization. So means in hybridization also you have to write six orbitals. So hybridization for this is yes, only one s will be there. Next will be p, that will be 3 p's, maximum 3 p's, sp3, total 4. So and remaining next will be d2, sp3 d2 hybridization for this. sp3 d2, 1s, 3p and 2d, 1s, 3p and 2d, that will be total 6 ligands. So sp3 d2 hybridization for this. You have to remember this sp3 d2 hybridization. Based on hybridization, you will decide the geometry. Whenever this sp3 d2 hybridization comes, or there will be six ligands, the geometry will be octahedral geometry. Octahedral geometry. Actually, there are octa means 8. The geometry of this complex, there are four ligands are the plane. In a plane at the corner, square plane are four ligands. One ligand will be above the plane and one more ligand will be the below the plane. If you join all the ligands, all the points, you will get at above the plane you will get four faces, below the plane you will get four faces. So there will be total 8 faces. So for that the geometry will be called as octahedral. So for 6 ligands, sp3d2 octahedral, remember this for this. Okay, now the final one is magnetic property. Magnetic property. There will be two magnetic properties. One will be paramagnetic property, paramagnetic, and one more will be diamagnetic. Paramagnetic, if it contains unpaired electron in their central metal atom, unpaired electrons will be there, so then it will be paramagnetic. If does not contain unpaired electron, means it will be diamagnetic. For this complex, fluoride of weak ligand, electrons will be not pair up, so it will be paramagnetic. For weak ligand, it will be paramagnetic. So these 3 points you have to write in examination: geometry, hybridization and magnetic property. If the question same with example comes in examination, if you write these three, you may get 3 marks, or at least you may get 2.5 marks also. Okay, so only remember these 3 points. It is very easy to write from this part in examination. So I will take one more example. So CO, I will change the ligands. I will change the complex. Example: CO NH3 6 times with plus 3 charge. Here also cobalt as a central metal atom, and NS3 amine ligand. Amine ligand is there. There are 6 ligands are there. Here this amine ligand, ammonia ligand, is a strong ligands. Okay, for this also you have to write hybridization. Now 6 ligands are there, means you have to write 6 orbitals. For the strong ligand, pairing takes place against Hund's rule. So here hybridization starts from D, that is 2 times, remaining only 2 d orbitals will be there. So d2 and only one s1 and remaining p. d2 2 plus s1 plus remaining for 6 there will be 3. So d2sp3 hybridization. For this complex the hybridization is d2sp3. You can see, you can observe in previous example the hybridization is sp3d2. In this example the hybridization is d2 sp3. Both are not same, there is a lot of difference. If you observe here, this will be d2 sp3. In this d will be 3d orbital. This d is from 3d, 4s and 4p. 1s2 2s2 2p. You can remember 3d 4s 4p. In that previous example with S 4S 4P and the next D will be from 4D. 4S 4P 4D will be there. Here 3D 4S 4P will be there. So for this also D2 sp3. Previous example sp3 D2, for this D2 sp3. And whenever 6 ligands comes, directly you can write the geometry, that is octahedral, like same octahedral geometry. Okay, so magnetic property, definitely there will be two para and diamagnetic. Strong ligand pairing takes place against Hund's rule. There will be no unpaired electron for this diamagnetic. The magnetic property is diamagnetic. For this one marks, for this one marks, for this one marks. You will get in examination if you write these 3 points. Remember this example. Okay, you can practice it once, 2-3 times practices. It will be easy for you people. So now, without wasting your time, directly I am going to third example. So NiCl4, next example. So the question will be like this same, based on using VBT, account for geometry, hybridization and magnetic property of NiCl4 2 minus. Here central metal atom is nickel Ni and chloride Cl. Chloride is a ligand. So there are 4 ligands are there. 4 ligands. Now chloride is also a weak ligand. No hybridization. Here 4 ligands. You have to write 4 orbitals in hybridization. Simply, directly you can write for weak ligand, the hybridization will start from S, P, 1 S and remaining will be 3 for 4 ligands, sp3 hybridization. The hybridization is sp3. It's a very simple sp3 hybridization. Whenever the hybridization sp3 comes, memorize it. So the geometry will be tetrahedral geometry. For sp3 hybridization, tetrahedral geometry. So here weak ligands pairing does not take place against Hund's rule. There will be unpaired electrons. So magnetic property will be paramagnetic behavior. Magnetic property, paramagnetic geometry, tetrahedral hybridization sp3. So for this complex, so I will go to one more complex. The complex will be NiCN4 minus 2. The question will be same. You have to answer the hybridization, geometry and magnetic property for this. Okay. Now here NiCN4, this cyanidoligand is a strong ligand. So here also 4 ligands are there. So hybridization start from D for this complex D. Only one D, not 2D like before. Only one D. D and 1S, yes, and remaining will be P. 1D, 1S. Then remaining how many? There will be 2. So DSP2 hybridization. It's a very simple DSP2 hybridization. and whenever the hybridization will be DSP2, the geometry will be square planar geometry. Geometry is square planar. For this 1 marks, for this 1 marks you will get. So magnetic property, this is strong ligand. For this, there will be no unpaired electrons in central metal atom, so the magnetic property will be diamagnetic. Diamagnetic. It's simple. So DSP2 hybridization, square planar geometry, and diamagnetic. Okay, so these will be for 4 complex. Out of these 4, one will be compulsory in your supplementary examination. You will get easily 3 marks, or else less than 3 marks you may get. Okay, so now I know it will somehow difficult to remember all this. You have studied one by one, but at a time, all the 4, it will be somehow difficult to you people. So I have also one technique to remember all the 4 complexes. To write this question, you have to remember all the 4 examples. I will draw one table. First one will be the hybridization. Hybridization. Geometry. Here magnetic property. I'm writing quickly to save the time. You write properly. I will write here 4 examples. Start from this COF6, 3 minus or minus 3, CONH3 6 times, plus 3 charge or 3 plus, NiCl4 minus 2 or 2 minus, NiCN4 plus minus 2 minus. So for these 4 complexes, you have to remember these points. Okay, 4 complexes at a time. So now for COF6 and CONS3, both are having 6 ligands. Directly you can write geometry. You can remember geometry. That is octahedral. Octahedral geometry. This is also octahedral geometry. You can't write for these two. You have to first see the hybridization. Then only you can write the geometry for these 2 complexes. So I will come to this. COF6 and CONS3 6 times, 6 ligands. Hybridization D2sp3 or sp3d2. For this weak ligand, so start with sp3d2, sp3d2, and this will be having strong ligand, so start with d2 sp3. Both are not same, so sp3d2, d2 sp3. So hybridized geometry, octahedral. Weak ligand, paramagnetic, unpaired electrons, paramagnetic. Strong ligand, diamagnetic. There is no unpaired electrons, diamagnetic. Okay, for these two you can easily remember. Now for these two having 4 ligands, the hybridization either sp3 or dsp2. This will be weak ligand, start with sp3. This is having strong ligand, starts with dsp2. sp3, dsp2, 4 ligands. Whenever sp3 hybridization comes, the geometry is tetrahedral. Whenever dsp2 comes, the geometry will be square planar geometry. Okay, so now for a weak ligand, unpaired electrons are there, paramagnetic pair. For strong ligand, there will be no unpaired electrons, the magnetic behavior is diamagnetic. Okay, so if you remember this chart, you can easily write the question number 25 or 26 in your examination for 3 marks. So you have to remember. Quickly once again, I will explain. This is having 6 ligands. This is having 4 ligands. Weak ligand. 6 ligands octahedral, weak ligand. Based on this you have to write. Weak 6 ligands sp3 weak, start with S, sp3d2. Weak ligand start with S, 4, so sp3. For 4 ligands, sp3. So for these two. Based on this octahedral, based on this geometry, it will be tetrahedral. Weak ligand paramagnetic, weak ligand paramagnetic. So for here 6 and here 4. Strong ligand, strong ligand. 6 strong ligand start with D, D2 sp3. 4 weak ligand starts with D, D sp2. Based on this geometry, octahedral. Based on this geometry, square plane. Strong ligand diamagnetic, strong ligand diamagnetic. If you write this as a, in your, don't write this chart. You have to write only 3 points on that question or based on that example. Don't write all these things. Okay, this is only for your practice or remembrance. You can remember by seeing this. Okay, this is for this question. Thank you.